Okay, we are back here for 4.1 notes, part 1B. So we're going to start here with, take that off here. So we're going to start here with the warm-up. So I would pause your video, try these two problems showing some work without a calculator, and then when you're finished, you can go ahead and restart the video. I will give the answers, and then I will go through them in case you miss any of them. Okay, at this point, you should have worked these problems out on your own without a calculator. So for number 1, you should have gotten 150 degrees. For number 2, you should have gotten 4 pi over 3. And for number 3, as you drew this in standard position, you want to make sure you have an arrowhead on the positive x-axis. You should be going clockwise 40 degrees, which is not quite halfway. Draw an arrowhead for direction and then an arrowhead for your terminal side. And that lies in quadrant 4. So remember the V is 5, so 1 before 5 is 4. So if you didn't get those, the way that you would get those is you would take 5 pi over 6. You would multiply, again, you're converting degrees, so degrees go on top. If you got these, you can go ahead and fast forward, but if you didn't, we would cancel those out. 180 divided by 6 is 30. 30 times 5 is 150. On the next one, you're converting to radians, so 240 degrees. Again, you want radian, so you'd put pi because it represents the radian measure, pi over 180. Again, the degrees now cancel. You can cancel the zeros. And from there, you can take a 6 out of both of those. So 24 divided by 6 is 4. You have a pi. 18 divided by 6 is 3. And I already talked about the third one. Okay, so for 1, part 1B, we're going to talk today about coterminal angles. So we're going to even use that co and terminal, talk about what that means, and then being able to find an arc length. So how do we find that as we start applying what we're doing? So to talk about a coterminal angle, co means we're sharing something, terminal means where it ends. So two angles with the same or shared initial and terminal side. So if we're co-captains, we're sharing the concept of captains. If we're co-chairs, whatever it may be. But in this case, co-terminal, we're going to make sure we start at the same place, but we have the same terminal side. So the idea is we're in standard position, okay? We would start and end in the same place, but we could be going one clockwise, one counterclockwise. We could have wraparounds. There's a variety of things that can happen. So we talked a little bit about this when I first graphed in standard position, but if I want to try to figure out how to get these, the idea, remember, is that one complete revolution is 360 degrees. So if I have an angle, I'm just going to give you a quick sketch here. If I have an angle, let's just say that is 20 degrees. Okay, I know that's bigger than 20. We'll say 40. That looks more like 40. Okay, and it's going clockwise 40 or counterclockwise 40 degrees. Well, I could go clockwise 320 degrees. So we have 40 degrees on the positive end and negative 320 degrees on the negative side. Well, those, if you disregard the positive negative, are adding to 360. But if I start with 40, I would subtract 360 degrees to get negative 320. If I start with negative 320, I would add 360 to get to 40. So the way that we find coterminal angles in degrees is we either add or subtract 360 degrees. Now, we're also talking about radians, and we got to get more familiar with those. So remember what's equivalent to 360 degrees in terms of radians. That would be 2 pi. So we're going to add 2 pi and subtract 2 pi. And this gets right back to that radian worksheet we did, just to try to make sure that we were able to add with common denominators. This is going to get us right back to that. So we're going to be practicing some of that. Okay, so in part 1A, I think we ended on example 10. So I'm going to get to example 11 here. So we're going to start with 50 degrees. And we're going to read those directions because those are obviously important. We're going to give two coterminal angles, one that's positive and one that's negative, that are in the same units. So this is in degrees. So we want to be in degrees. Now I'm going to sketch this just again to give you the visual. Okay, so if we're 50 degrees, we're a little bit more than half. So there's 50 degrees. So what I need to do is I need to go on a clockwise journey. Okay, start and end at the same place. So the way I would do that is I would just subtract 360 degrees because I'm subtracting a complete revolution. Because really what's happening is I name my angle starting from the initial side, but really what's happening for me to find it is I ended here. So I'm actually subtracting 360 degrees from there to get back to where I was. I'm turning a full revolution. So that's going to give me negative 310 degrees. So that's what that red angle would be, negative 310. But I'm also going to take 50 degrees and I'm going to add 360 degrees. And that's going to give me positive 410 degrees. So those are going to be my two answers. Now the positive 410 degrees, if you're curious there, remember I ended right here where that pink is, so starting and ending. Well, that just means, let me see if I can get kind of a bright color, this green here. So if I end there on my terminal side, I'm just going to go another 360 degrees all the way around. So I already went 50 degrees, and then I'm adding 360 degrees more. So that's visually what is happening here. Okay, I'm going to come over here to the right for example 12. So example 12 is 2 pi over 3. So again, we're trying to get a positive and negative coterminal angle for 2 pi over 3. So to get a negative one, I'm going to subtract, okay, but I'm going to subtract 2 pi here. So again, going back to that radian worksheet, in order to subtract 2 pi, I have to have a common denominator, and that would be a denominator of 3. So this would be like 2 pi over 3 minus 2 pi times 3 is 6 pi over 3. Think about it, guys. 6 pi divided by 3 is 2 pi. Okay, they're equivalent. So then when I do 2 pi over 3 minus 6 pi over 3, 2 pi minus 6 pi is negative 4 pi. My denominator doesn't change. But then I also have to take 2 pi over 3 and add 2 pi. So I want to add 2 pi, I'm adding 6 pi over 3. I'm adding the same thing because it's equal to 2 pi. So 2 plus 6 is 8, so we're getting 8 pi over 3. So those are my two angles. One is positive and one is negative. So 8 pi over 3 and negative 4 pi over 3. So if we do one more here, example 13, what if we have 750 degrees? So 750 degrees, if we think about that, that's obviously more than one revolution, which is fine. So I'm going to start, because it's positive, I'm going to subtract 360, and I'll just do it underneath here. You can do it out to the side or underneath. So we take 750 minus 360, we get 390 degrees. Well, that's a positive coterminal angle. But then if I take my 750 and I add 360 degrees, well, obviously that's going to give me another positive answer. That's going to give me 1110. Well, I don't want another positive angle. I need another negative angle. I need one positive and one negative. So what I want to do instead, because this is a wraparound, this is showing that I'm wrapping around more than once. So I'm going to subtract from my 390 another 360. I'm just going to continue subtracting revolutions. Well, that's going to give me 30. Okay, well, that's still positive, so I'm going to subtract another 360 degrees. So if I take 30 minus 360 degrees, I'm finally to a negative, so negative 330 degrees. So if you're typing this into Pearson, 390 would be an appropriate positive angle. 30 degrees would be an appropriate positive angle. 1110 would be an appropriate positive angle. Okay, but recognizing that if it's a wraparound, if it's more than 360, then I'm going to have to keep subtracting 360 to get to a negative. If it's a negative number, I'm going to have to add 360 to get to a positive. Let's just use some common sense there. Okay. So that's what we have for those coterminal angles. Now we're going to find some others. So let's say we want to do this now. We want to find a positive angle, so it's not any negatives, a positive angle that's less than 360 degrees or 2 pi, which is 2 pi radians, but is coterminal, so it has the same initial and terminal side as the given angle. So this is where we're going to have to think, am I going to add or am I going to subtract? And will it be 2 pi if we're in radians or 360 degrees if we're in degrees? So I think we're up to example 14. So we're going to start with negative 7 pi over 6. Again, these radian measures are going to become more familiar to you over the next few weeks. So negative 7 pi over 6, I need a positive angle less than 360 degrees. Well, first off, this is negative. So the only way to get out of the negatives is to keep adding numbers. Think about if you have a bank account that's negative, you got to put money in it. So we're going to keep adding, and we're going to add revolutions. So in this case, we're going to add 2 pi because we're in radians. So we're going to take negative 7 pi over 6, and we're going to need to get a common denominator with 2 pi. So we're going to multiply top and bottom by 6 because that's my denominator. So that's 12 pi over 6. So negative 7 pi over 6 plus 12 pi over 6. Negative 7 plus 12 is 5. So we are at 5 pi over 6. So if we were to graph, negative 7 pi over 6 clockwise would be the same as graphing 5 pi over 6 counterclockwise. Okay, example 15. Let me back up. 5 pi is between 0 and 2 pi. It's positive. It's less than 2 pi because remember, 12 pi over 6 is equal to 2 pi. So 5 pi over 6 is obviously less than that. So example 15, 610 degrees. Well, 610 is obviously more than 360. So it needs to be less than 360. So we're just going to subtract 360 degrees. So when we do that, we're going to get 250 degrees. Well, it's positive and it is less than 360. So there's my answer. If I were to subtract 360 again, I would get negative 110. So I don't want a negative, but it would also be coterminal. Okay, example 16, 13 pi over 3. If you're feeling confident, maybe pause the video, try this on your own. So we would be doing if we were in class. So again, I have 13 pi over 3. I need it to be less, in this case, than 2 pi, because this is in radians, but it's got to be positive. Well, it's already positive, but in terms of pi over 3, 6 pi over 3 would be less than 2 pi. So I'm going to have to subtract 2 pi to get it to be smaller. So again, 13 pi over 3 minus, multiply by that common denominator. That's where that radian worksheet comes in handy. So again, if you didn't do that, okay, or you weren't in the class at that time, you might want to go back and look at that. So minus 6 pi over 3. Because 6 pi over 3 is equal to 2 pi. So 13 pi minus 6 pi would be 7 pi over 3. The problem is 7 pi over 3, while it is positive, it's not less than 2 pi. Again, 2 pi is the same as 6 pi over 3, so 7 pi over 3 has to be more than that. So we need to subtract another 2 pi, which again would be subtracting 6 pi over 3, because that's equal to 2 pi. So when we do that, we get 1 pi over 3, or pi over 3. So again, that's positive, and it is less than 360, or 2 pi. Okay, because again, 2 pi in terms of pi over 3s is 6 pi over 3. 6 divided by 3 is 2. So there's a couple, 6 different examples on coterminal angles. So very, very important, very, very critical and key as we move through our lessons with trig. So that gets us to our third objective here, which was to find coterminal angles. So our last objective, find an arc length. Again, an arc length, as I mentioned in the last lesson, is the crust. Okay, if you like the crust of pizza or pie, we're talking your thing right here. Okay, arc length. The length of an arc. That's what we're discussing here. Okay, what's the length of our arc? So to start off with, what in the world are we talking about? So again, we have this radius. Okay, I talked about it when I defined a radian. Okay, we're going to come up here. We have another radius. Now remember, whatever this theta is, it's only 1 radian if the arc length is the same. So I'm going to draw the arc length. I'll draw it in purple here. Well, obviously, if we look at this, this is not the same. So I don't know what theta is, but we typically use S for arc length. It can also be an L, but your textbook uses S to represent arc length. So we'll use that. So the way that we find the arc length, it does have something to do with circumference. Remember, circumference is all the way around a circle. And I told you that circumference was 2 pi times the radius. And that's because 2 pi is equal to 1 revolution all the way around. Okay, so it's equal to the entire theta of a full circle. Okay, that's the idea there of that fact that circumference is 2 pi r. Well, we're not talking about a full circle here, and we're talking about arc length. We're talking about a piece of it. So our formula is S equals R times theta, but the key is that theta must be that central angle in radians. If it's not in radians, then we must convert it to radians. Because again, it goes back to the fact that it's 2 pi, however many radians in a complete circle. Now, if you're in physics, you might have heard of like x over 360 times radius. And that's the idea that you're converting that, actually times 2 pi radius, excuse me. That's because you're doing the conversion in the problem, okay? So again, r is radius. You should know that, but I'll go ahead and write that. Okay, so let's use it. So we want to find the radian measure of a central angle of a circle of a radius 6 yards that intercepts an arc length of 8 yards. So you're going to be asked to list out what you know with labels and with variables. So what we know is we have a radius of 6 yards on a circle. So radius is r. We want to make sure when we're thinking about a circle, we know if we have the radius or the diameter. So let's distinguish between the two. We know that diameter is equal to 2 times a radius, or a radius is half of a diameter. And then we know it intercepts an arc. So we have an arc length of 8 yards. So that's S. So S equals 8 yards. So we're trying to find the radian measure of the central angle. So that's theta. And it does want it in radians. Well, the good news is that's what our formula will do. So we're going to list out what our formula is. S equals R times theta. We're going to sub in what we know with the labels. The labels are going to be important as we start approaching word problems in the next section. So 8 yards equals 6 yards times theta. And here's why the variable or the labels are important. To find theta, we're going to divide both sides by 6 yards. The yards are going to cancel on the right, as do the 6's, but on the left, the yards also cancel, and we're left with 8 over 6, which is 4 over 3. Notice we do not have any labels because, remember, radians are dimensionless. So we know this is in radians. 4 over 3 is in radians. There's no degree sign at all in the problem. Okay, so the idea that the label canceled out is solidifying the fact that this angle is indeed in radians. So the radian measure would be 4/3, 1 1/3. Okay, so a little bit more than 1. Okay, and that's because the arc length is a little bit more than the radius. Remember, if they were both 6, this would be 1. Okay, 1 radian. Okay, the last one here, we have a circle that has a radius of 10 inches. We want to find the length of the arc intercepted by a central angle of 120 degrees. So again, we're going to write out what we know. So we have a radius of 10 inches. So we're going to say that R equals 10 inches. So make sure you keep the label. We're looking for the length of the arc. So I'm going to leave a little space. We don't know what S is. That's the length of the arc. If it's intercepted by a central angle of 120 degrees. So that's theta, 120 degrees. So you could draw a picture if that helps you. So our formula for arc length is S equals R times theta. But remember, theta must be in radians. Right now, our theta is in degrees. So the first thing we're going to have to do is convert, hence the reason we learned converting from degrees to radians. So if we're 120 degrees, how many radians is that? So the radians are going to go on the top. So there's 180 degrees in pi radians. Again, the degrees will cancel, the zeros will cancel, 12 and 18, can take a 6 out. So we get 2 pi over 3. So we cannot use these formulas until we have our angle. Anytime we're talking about an angle in a formula here, we're talking radians. So S equals 10 inches times 2 pi over 3. Now let me do some dimension analysis again. If we multiply these, we get 10 times 2 pi, which is 20 pi. It's still divided by 3. But notice the label is inch times a dimensionless label. So we just get inches. And I believe your homework will ask for an exact value in terms of pi. So 20 pi over 3 inches. And then we'll ask for a decimal approximation rounded to whatever it says. So then you would just take 20 times pi, divide it by 3, you would get 20.94. Because remember, pi is a little bit more than 3.14 approximately. So when you divide it by 3, it's close. Now, guys, let me just show you what would happen if you forgot to convert. If you forgot to convert here and you just multiplied 10 inches times 120 degrees, 10 times 120 is 1200, but you have inches and degrees left. Guys, I've never heard of an inch degree. Okay, that is not what we have. So that dimension analysis is so important that when you take an inch times a degree, that doesn't make sense. Okay, so converting to radians because they are dimensionless. So that finishes up 4-1 notes part 1. That's part 1B. So that will allow you to finish the assignment in Pearson. Again, if you have any questions, please reach out. I hope you have a great day.